theta over 2. I got you. Like this. And what was that set equal to? Radical 3. Positive. Okay, like that. Hey guys, this one I don't think it's going to be too hard, but I'd like to write out the general solution, particular solutions. I thought we were doing a good job of that yesterday, and then we'll maybe go from there. What's involved here? What's step 1?
And that's 0,3 pi by 2.
Oh, they give me particular intervals. What was it again?
0,
0 up to,
3 pi over 2.
and was it open or closed? Like that?
Yes.
Okay. They're asking us just find the answers caught in that interval. So guys, without just sitting there and guessing at angles, numbers that fall here, and then testing them to see which ones work, we need a system here, a way to do this. Anyone have an idea? Anything at all? And if theta over 2 is equal to radical 3, and you know I've got to refer back to the unit circle. If anyone recall on the unit circle itself, somewhere where tan, y over x would give you radical 3 to begin with? That would help me. Tan of what angle or angles have you seen, y over x, and you get a radical 3, positive radical 3? Is it 60 or pi over 3? Let's see if it is. Now pi over 3, if I recall, you help me out here. On the unit circle, was it for an ordered pair? It might be. Was the ordered pair for 60 or pi over 3 that? Okay, now if I place y over x, you gave me tangent. If I place y over x, which is tangent, I think I see already, and we end up with the radical 3. Is that true? Is that true? Okay, so it is pi over 3. Is there another one?
Yeah.
And I have to consider and see what happens here. What's the other one?
4 pi.
4 pi? And on the unit circle, guys, 4 pi over 3, I'm doing my math here, 240 degrees. Which quadrant are we in at 4 pi over 3? Are we in quadrant 3?
Yeah.
And is tan y over x also positive in quadrant 3? And they want a positive square root of 3, so that's another possibility. And I'll consider 4 pi over 3. PK, since I'm down in quadrant 3, were the coordinates, if I need to know what they look like, were they both like this?
Yes.
They're both negative. Okay, so I gotta consider both. Now why would I not consider quadrant 2? Yeah, because y over x there would give you a negative. And why not consider quadrant 4? Same thing. If I place y over x, I get a negative, and they want a positive radical 3. So you say, Ramsey, what are you going to do with all this? Well, I got to consider first that this, right here, theta over 2, could be representing, let's try pi over 3 first. Pi over 3, and they want all angles, not just the unit circle angles, plus, now I need a period number that will make things repeat. Now I got to be careful here. Does anyone recall what the period was for tangent? Now I'll tell you this much, it's not 2 pi. It was 2 pi for the others. It's just pi. So pi over 3 plus pi k, where k is an element of the integers. And I'll deal with that, and we'll come back to it, guys. Step 2, also I must also consider theta over 2 could be representing, like she gave me dk, 4 pi over 3. We'll see what happens here. And the period number pi to make things repeat. And k is an element of the integers. Now I gotta solve each one of those. There's 2 cases here. In fact, I think June was telling me yesterday I left out one of those in my discussion. Guys, we've got both of them here. To solve for theta, let's multiply everything by 2, and watch carefully. If I multiply everything by 2, and we end up with this, look at the end here, that changes down to 2 pi k, where k is the element of the integer. And now, if I jump down here and do it, the same thing down here, solve for theta, multiply by 2, we end up with 8 pi over 3 plus 2 pi k, where k is an element of the integers. So guys, these are so-called general solutions. Now do watch, I've got so much going on here, watch out for mistakes here that I could make. This is the general solution. Both of these are general solutions. Now, PKs tell me, no, professor, they want particular solutions. And where should they be? Caught between these two. Now, what might you do as a clever student? You have all of them right now. Now, what might you do to find just those that are caught between 0 and 270? Give me an idea.
Choose one.
Tim, like what?
It's like 4 pi over 3 is more than 180, less than 270, so it's okay.
Oh, I got you. So why not in this first general solution, k can be an integer. Let's write a few of those out. Replace k by integers. We'll start with 0 myself, and put a 1 in there, put a 2 in there, and see how much I can get that's caught here. I don't think, maybe not find too many. Let's let,
It's just one.
it might be, let k be 0. If I let k be 0 in this general solution, this term drops out. I'm left with theta to have a value of 2 pi over 3, that's 120 degrees. Is that caught between 0 and 270? So I'll accept it. Now maybe I can find another one. It all depends. I'm gonna try to let k be 1. That's an integer. If I let k be 1, guys, it looks like this. Theta is equal to 2 pi over 3. And if k is 1, this becomes 2 pi. On the end, oh my goodness, combined with a common denominator of 3, I can call that, I guess, 2 pi plus 6 pi, what's that, 8 pi? Is that true? Now, can I accept it? Well, it's caught between here and here, is it?
No,
And how could you tell whether it's not?
because more than 2, more than,
It might be, exactly. If you divide 3 into 8 pi, is that bigger than 2?
yes.
And then I can just go out to bigger than 2 pi here. So I don't think it's going to fit. Or you could change these to degrees, if it's easier for you, to see if it fits. Does anyone know what 8 pi over 3 quickly converted to degrees would be? Just out of curiosity. This is the answer, guys. That we have to determine whether we're going to accept. What's that in degrees? Anyone know what it is? If you use a conversion factor or do it quickly? I know 180 is always, pi is always representing what, 180? The way I do it, I just go ahead and put 180 in for pi.
It's 420.
Is it 480? 8 times 60? So 480 degrees. If that would help, she says, professor, is supposed to be caught between 0 and 270. So definitely 480 is not going to work. It does not fit the interval, right? Okay, so I can't use it. So we'll stop there. We can't, looks like we can't use anything else. This one may give me, look what happens here. If I let k be 0 down here on this one, and this term drops out, I'm left with what? 8 pi over 3, also down here. And I think we've already determined what? It can't fit. So after all that, what's the answer? What's the answer that they want for this equation based on, they want it in this interval?
2 pi over 3.
That's the only answer. Are there other answers? There are infinite number of answers, but that's the only that fits caught between 0 and 3 pi over 2. You guys agree? Or not? Okay. Now, if I did this, PK, if I had opened this up and said, maybe here, go all the way up to 4 pi. Now, might I be able to pick up others as part of the solution if I opened up the interval? If they had the interval from 0 to 3 pi over 2. So it all depends on what that interval is that they want you to find those particular solutions. And she says it was 3 pi over 2. And guys, looks like we are finished. Okay. DK, let's work maybe one more. I think we sort of get the idea here. What's the next one look like? Give me another one.
Secant,
Talking about secant? Of what?
parentheses, 3 pi over 2. No, 3 theta,
Oh, 3 pi?
3 theta, sorry.
Let's see, let's see.
3 theta over 2.
Well, 3 theta over 2 is equal to a negative 2. Gotcha. 3 theta over 2 is equal to a negative 2, was it?
Yes.
And what was the interval they wanted us to find the answers?
Bracket 0 to 2 pi.
Gotcha.
Parentheses.
There you go, thank you. Okay, guys, let's run through this one. And then we'll leave this. I think you guys sort of get the idea. Oh, by the way, did I work one of these yesterday that we had actually had to let u be something and turn it into a quadratic? And those are the nicer ones. You let u be something and turn it into a quadratic and go from there. This one, not a quadratic. Does anyone recall where, here goes again the unit circle. We're on the unit circle with 1 over x, which is secant. Give me negative 2.
So it's
If it's not there, I can't, how do you guys do this?
Cosine equals -1.
Okay, I'll get to which quadrants first. Which good, I heard you. Which quadrants would 1 over x, which is secant, give me a negative to begin with?
Fourth.
Is it quadrant 1? No, everything's possible in quadrant 1. Is it in quadrant 2?
Yes.
Okay, so quadrant 2 is a possibility when I find the angle. And how about 3? Is secant negative in quadrant 3?
Yes.
Quadrant 4? No. So those are the 2 quadrants in which this angle I'm searching for must fall. And we'll see if we can use it for secant to be a negative. Now, they want a negative 2. Guys, I would do this, see if you guys would mind. Secant sometimes can be difficult to work with, but we can work with it. You could change this quickly into, see if you guys agree, which might be easier. Is that saying the same thing? Are secant and cosine reciprocals? You might want to change it to cosine and deal with it, rather than secant. So it might be easier to deal with it in secant and just do a reciprocal. I still got the -1/2, I'm still in quadrant 2 and quadrant 3. Now that might be easier to find -1/2 on the unit circle. Guys, can anyone tell me the size of the angle in quadrant 2 maybe, whose cosine is -1/2?
5 pi over 6.
Is it 5 pi over 6? Cosine is the x. You sure? Now there's 2 pi over 3, you guys don't mess up. 2 pi over 3. What were the coordinates for 2 pi over 3 on that unit circle, just out of curiosity? Was it -1/2 and radical 3 over 2?
Yes.
I think. Was it on the unit circle at 2 pi over 3? At 2 pi over 3. Yeah. And we want what? Cosine to be a -1/2 and cosine is x. So 2 pi over 3 is it. Now can you tell me the size of the angle down in quadrant 3 that we might want to consider? 4 pi over 3? And I think down there it was probably this. DK, you can check and make sure I got the signs right here. Was it?
Yes.
Okay. Still, the x is -1/2. So it's those 2 I'm considering. Woo, glad we're doing this, a little recap. Now, what does that tell me? That tells me that this, 3 theta over 2, look at this, is representing either 2 pi over 3, and I am going to use my period number to be 2 pi k. Okay, it's an element of the integers. I'm working with cosine now, guys, and the period for cosine is 2 pi. Or, let me do this. Or 3 theta over 2 in that problem could be representing the other angle. And we'll do it here. 4 pi over 3 plus 2 pi k. K is an element of the integers. Okay, looks like 2 pi over 3 was used in that last one. Would you guys agree? So it could be this, representing this, or it could be this, based on that up there. Then you gotta solve each one of those. Okay, I'm gonna do it fairly quickly, see if you guys agree. First one here, we'll multiply everything by, call this number 1, and this number 2. On number 1, multiply everything by maybe,
2/3.
you could, 3/2, multiply everything by 2/3, you could. And see what happens, multiply everything by 2/3. If I multiply everything by 2/3 though, and we end up with what? Theta here, help me out guys. If I multiply this by 2/3, that becomes what? 4 pi over 9? Oh boy. And if you multiply that last term also by 2/3, what does that become?
4.
4 pi over what? 3? K. Look at that. See if you guys agree. Now I've got theta, which they want. Wow, this is wild. Wild. Down here, I guess the same thing, multiply by 2/3. If they want to solve for theta, so if I multiply everything by 2/3, we end up with theta is equal to, right hand side 2/3 will make that 8 pi over 9. Do not be making a mistake. Multiply the 2 pi by 2/3, you're going to end up with what? 4 pi over 3 again, I guess. K, where K is an element of the integers, and you have another so-called general solution. Wow. And then we'll go through and let K be 0, let K be 1, let K be 2, play around with it and see how many answers can I get from those. And she says, Professor, you may look at as many as you wish, but there must be caught between these two.
Sponsor.
Okay, those are my particular solutions. Now, before I can jump in and start doing that, just out of curiosity, suppose on your exam, you saw, now, just saying this on the side, saw this. Initially, it was the problem. Secant of 3 theta over 2 is equal to a -1. Tell me on the unit circle, where have you seen 1 over x equal to a -1?
Just
Oh, well, you had better on your business. Where on that unit circle have you seen 1 over x, which is secant, come out to be a -1?
180.
Tell me again.
180.
180. Pi. And what were the coordinates at pi on that unit circle? I think it was what, -1, 0?
Yes.
And secant is 1 over x, so you're replacing 1 over a -1, that would definitely give you a -1. Is that true, guys? Or you can do it down here in the cosine. But the reason I'm pointing that out, are there any other angles besides the pi he gave me, or 180, that would give me -1 if that had been -1? Is there another angle on that unit circle we're overlooking that when you place 1 over x, you get -1? No, sometimes you luck out, there's only one possibility. So that would be me setting this equal to pi plus 2 pi k. And that would be the only one you have to worry about, just one solution here. We were given this, which I changed to this to make it easier. This one gave me 2 to consider. All that logic there? So you have to go to that unit circle. How many am I to consider to begin with? Guys, we got the solutions here. Let me let K be 0. Oh, by the way, PK, I see a 9 in my work here. That bothers me. Maybe, so I will not leave anything out, maybe I better go back and write this constraint as this. I can go from 0 up to 18 pi over 9. That's the same as 2 pi. And I'll keep a better track of, because I see some 9s here, of what I can accept. So guys, I can go all the way up to 18 in terms of 9 there. Let's find them if we can. Okay, is let K be zero. Usually I start with zero. One of my students once said, Professor, could you start with a negative? Could you let K be a negative, -1, -2? You could. As long as you get inside that interval they want. I usually start with zero. Here we go. Replace K by zero, that term drops out. We are now considering for an answer this. Please tell me, would that fit here? In between 0 and 18? Yes. I may get another one here. Let's replace K by 1. I'll put an integer in there. If I put a 1 here, right here for K, guys, help me out. You got 4 pi over 9 plus, if I replace K by 1, what is that, 4 pi over 3? And a common denominator of 9. Can someone do that quick before we put those two together with a common denominator of 9? How much is that? Is it 16? 16 pi over 9? Oh, this is interesting. May I use it?
Yes.
I can go up to 18. Now, I would think, Professor, can I try another one? I don't think I would try K is equal to 2. I think it's going to take me outside. Look how close I am already. Is that true? But if you let K be 2, you will get an answer, but it's going to go outside that interval. Now, do we have more to consider? Well, of course we do. Down here, let K be 0. As my K be 0, my second possibility, that second term drops out and leaves me 8 pi over 9. What a problem. And looking back, yes, I may use it. It's in there. Let's let K be 1. I gotta be careful if K is equal to 1, and we end up with 8 pi over 9 plus 4 pi over 3. And I'm here in what is 20? 20 pi, whoa. Is it 20 pi? If it is, does it go outside? All right. It would work, but it's outside the interval. So I'm going to put that, he gave you, what, 20 pi over 9? Which would work, but went outside. So guys, what are my answers? How many answers do we have here for this problem? We got, I think 3. We got 2 from up there, 4 pi over 9. Wow, what a workout. 16 pi over 9. And down here, 8 pi over 9, I think. And close that up. And I think those are the 3. You guys agree? Okay. Now, if, it all depends on the, when you see one of these on a quiz or a test, not a quiz, you go. On the exam, final exam probably. And it all depends on how much I place here. If I place 4 pi, which now would give you maybe more room, you might be able to pick this one up. It all depends on the constraint. But what she gave me there, we have just those answers. Now guys, I thought I'd do that for a little recap on solving equations. How's it look? It's going to take a little practice. You're not going to just walk in here and say, oh, I'm ready for the final exam, Professor. Yeah, but I don't know how to set these things up. Now, the one that you hope, I think, would be much easier to solve is one of those where you let U be something. I think I did one of those yesterday. Change it into a quadratic. Okay, guys, anything here to ask about? I love this little setup here. After you get this, then you let KB0, KB1, KB2, you start writing answers out. And then see if they fit here. You write as many as you can. Okay? Okay. DK, or is there anything else on there that we need to look at? Not equations, but what's the next section? And that is what? Establish? Yeah, we established, and did we try a couple of those yesterday maybe to establish? We did just 2, and it makes the 2 sides the same, right? We did 2 of those. How many did I have on that handout? Oh, there's one more. Let's see what it looks like. I'm interested to get back into those formulas pretty soon. Oh, yeah, guys, just about do it. Read that to me. Okay. Now this is not solving, this is part two, it says establish. If you guys are not ready for Math 7 after all this, oh my goodness. But I talked to my colleague Gregory at the top of the class. Read that to me.
Secant,
Okay.
over cosecant,
Okay.
plus sin secant, y,
Over?
over cosine.
Oh, cosine again?
Yeah.
Okay.
No, the first one is cosecant.
Oh, let's go seek it.
Yeah.
Okay. Okay.
Equal 2 tan theta.
Wow. Now guys, this is not solving, for goodness sake. This is where you have to show those two sides are supposed to be identical. This may require some thought behind the requirements. Left-hand side, looks like the left-hand side is the side I should work on. I like to change it into, make it look like this. Does anyone have an idea, what can I do over there? Yes?
Sine over cosine is tangent.
I could quickly do this. Now, Philip, I'm gonna sort of organize myself here. So I'm gonna leave that first term right now the way it is. And he wants me to quickly go down here and say, Professor, this is tangent. Beautiful.
So secant over cosecant is also.
But tell me why though, you gotta show me why.
So it's 1 divided by cosine.
Oh, there you go, hang on. So step two, that secant on top is the same as 1 over cosine. Know your identities. And cosecant is the same as what? 1 over sine?
Sine, yeah.
Like it is.
And sine goes in top.
You got it. And then you're telling me, if you actually do this, guys, does this really mean you cleaned up the first term? Does that say sine over cosine?
Yes.
Step three, this right here, guys. Says this, but hang on just a second. That's still Phillips tangent on the end, still hanging there. And then could I say sine over cosine gives me another tangent plus his tangent. Combined like terms, I've got two of them. And that's what they wanted. You're done. Now, for the sake of all of this, if I were a beginning student, I don't know. You say, wait, Professor, you're telling me that blocked off portion is that? Yeah, because it says 1 over cosine is being divided by what? 1 over sine? And you know what that means. That means 1 over cosine, what, times? Flip this over, form the reciprocal, and that's why sine over cosine there. And you're done. Now, one of my students mentioned she's going in, oh, she's not with me today. She's going into physics. I was just thinking about what we had to do over here, like KB0, KB1. Sort of reminds me of some physics applications. Okay, PK, is that the last one that was done? We're done then. Now, is it time for a new handout, or are we finished with that, or is there something in the back?
New,
What's that?
with everything, and we finished everything.
So we're finished with everything that I gave you?
No,
Oh, we're not?
Still 6.4.
Oh, 6.4, oh, there's more?
I mean, 6 recap and 6.4.
Oh, I recapped. Jeez. I'm not gonna do too much recapping. Okay, recap, yeah. I do wanna do something on that recap. And it's, then finally we get into the formulas, right? Guys, on the recap, I wanna point this out, Mr. Park. I noticed, I looked at what you sent out last night. I think you worked these out. No, you
the
gave
one-
the answers, didn't you?
Yeah, except the one we didn't cover yesterday, which is
No, you, the ones that we, I think I saw the answers for this.
yeah.
Yeah, you sent the answers out.
Yeah.
Which I appreciate.
Thank you.
June? Your work? Have you guys looked at her work? Lord. Wow. How she can just down and just everything is so perfect. Jeez. Okay. Okay, part three, guys, I'm gonna do one thing here. I see one thing I should do. And my TAs may have to help me out a little bit. Letter C, and that says, I think, find the value. How was it worded there? Evaluate or find the value?
Find the exact value of the given system.
Find the exact value. Gotta do one of them. Then we're gonna move on to those formulas, which will be much easier. Much easier. We'll finally get to it. And the one I want to do is that, the one I mentioned, what did you say there? Which one was it I wanted to do there? There you go. Oh, inverse cosine. Inverse cosine. Cosine of, PA, what did I give on the side there? Cosine of what?
10 pi over 9.
How much?
10 pi
Over
over
9. Over 9?
Yes.
Wow. Like that.
Yeah.
Okay. Woo! I see, my students looking at Professor, no way. What are you talking about here? Any ideas?
It's just 10
Here goes. I think I heard what the student thinks it might be. Look at this, guys. Let me think of a good way to do this. Darn it. Hang on. Suppose you were asked to do this. Inverse cosine on cosine. Let me give you an angle that you would recognize. Right now, 10, 5, or 9, for goodness sakes, it's not on that unit circle. So we're gonna get back to it. But let me give you one first on the unit circle, see if it makes any sense. Suppose this say cosine, let's say pi over 4. Now, what might you say the answer might be? I think it might be just merely pi over 4. Let's see if it is, though. Inside the parenthesis was something you do recognize. Cosine of pi over 4 on the unit circle, I think is radical 2 over 2. Is it? And then you have on the outside, though, that. And then you're back into the discussion on inverses. Now, does anyone remember the constraint placed on me for an inverse cosine? I think inverse sine, inverse cosine, inverse tan had certain constraints. Does anyone remember what it was for inverse cosine?
It's just the cosine.
Was it 0 to pi? Help me out. For cosine, inverse cosine. Is it true? Okay. Now, can anyone tell me that constraint there? What angle have you seen on the unit circle whose cosine is radical 2 over 2? They want the angle. Is it pi over 4? Right? And does it fall between 0 and pi by the constraint? So this is pi over 4, and therefore it looks like this is pi over 4, and it's beautiful. They match up. And what are you doing here? You're taking something like this. Please tell me, if you did this, then I think I asked you to do something like that on the last test. You find an inverse. They're talking about inverse. And I asked you to check it. I think I asked you to check it on the last test. And you do something like this. You place the function into the inverse, or vice versa. What are you supposed to get on the end for a check? And I ask you to find this. This is what it looks like. You're supposed to get X, aren't you? That's exactly what this looks like, except they have a trig function. You say the same thing though. They have an inverse along with the function, which is much like this. Makes sense the way it looks? And therefore the answer should be X, and guess what? It was on the middle, on the unit circle problem. It was, wasn't it? Now I heard a student think ahead for me, which I love. he's telling me, Professor, then therefore this one should be this. I would think so. Wouldn't you? I would think it's 10 pi over 9. Well, there's an issue.
Yeah, the interval.
Yeah, there, see, you said it. They placed constraints on us. This one we lucked out, because we fell between 0 and pi, that was the constraint for inverse cosine yesterday. Well, I'm doing the inverse cosine here, so I gotta make sure, look at this guys, that I satisfy that. 10 pi over 9. If it doesn't fall within that interval, like my pi over 4 did back here, I can't use it.
Yeah, they'll go.
Which means I have issues. Will 10 pi over 9 fall within that interval? And if you'd like to write like this, it's the same thing. Now, would 10 pi over 9 fit? No. But darn it, it's not as easily done as this one was. Is there an answer? Yes, there's an answer. But it's not 10 pi over 9. I can't use it.
It's negative.
Now, we got, well, and you start playing around with it, say, maybe it's a negative 10 pi over 9, Professor, or maybe it get even worse. Okay, so what I'm gonna do, I'm gonna sketch it first, but it's not working out for us. I'll try to find where it is. Guys, 10 pi over 9, please help me out on the, just sketching it. Where would 10 pi, I know this is pi here, which could be expressed as what, 9 pi over 9?
It's 200 degrees.
And I'm looking for 10 pi over 9, was it? Does that mean maybe down in quadrant 3? I just need the location. So my angle is down here in quadrant 3. And if I need it, I know the signs of those. Oh boy. Inverse cosine says I should be here. I should be between 0 and pi. I can't change that, that's given. It's a constraint. I should have been here. Either quadrant 1 or quadrant 2. Where am I? I'm in quadrant 3. I'm outside the constraint. You may say, Professor, it's not an answer. Let's see what happens here. I saw Mr. Park giving that answer last night when I looked at your work. So you gotta check your work. Yeah. Now, does anyone have an idea?
Just opposite direction.
Almost. I'm in the wrong quadrant. Oh, by the way, can anyone tell me what the size of this little angle right here is? I know the whole thing is 10 pi over 9.
200 degrees.
No, if that's 9 pi over 9. So what might this little piece down here represent? Is that pi over 9? So put them all together. Is that 10 pi over 9? If I say this little angle down here must be this. This little angle right here must be pi over 9. But I move it. It's in the wrong quadrant. And you're talking about crazy? Every time I teach this, this is crazy. It's in the wrong quadrant by constraint. I should be either in 1 or 2. I can't be in both. So let's think about this. I'm down in quadrant 3. I go to cosine. What is cosine, the x coordinate, down in quadrant 3 to begin with? Is it negative? Is cosine negative down in quadrant 3? Now, which of these two where I should be, do I retain that negative? Is it first quadrant where everything's positive? Or is it the second quadrant? Is it the second quadrant where I retain that negative? That means my answer I'm looking for should have been here. Or better use another marker. Should have been in quadrant 2. If you're talking about a crazy problem, I'd probably give that as an extra credit problem. Here's what you're looking for. Now you're in the right quadrant. And by the way, you're caught down between 0 and 180, which you should be by constraint. Yeah, can anyone tell me the size of the angle? And that's the answer. What's the size of that red angle?
160.
I'm putting in radians. Is this little angle up here the same as this? Put 5 or 9 there. They're equivalent. Now with this one, what would you do then? What's my final answer? I want the size of this angle right here. That's my answer. The where was it? The red one. That's my answer. that. And I know that's 5 or 9 in the corner. So what might you do to get what I'm looking for? That's 9 5 or 9. Subtract what? 5 or 9, would that leave what I want? So what is 9 pi over 9? Subtract pi over 9. 8 pi over 9. Are you kidding? Are you kidding? I'm gonna have June check this for me. Darn it. Why did it not come out to be nice and easy like this? Because of that constraint. June, do me a favor. June, maybe I check here. Whew. Lord. There's a good way to do this. If we do it in degrees, it might be easier to do it in degrees. We quickly convert this to degrees for a 10 pi over 9, 9 into 180 is 20. 20 times 10, 200. Find cosine 200 degrees for me, and then inverse cosine of that. Or just do it all in one swoop.
Cosine of 200 degrees.
Yeah, 200 degrees. I think it's 200.
It's
And then inverse cosine of that answer.
uh-huh.
Let's see what you get.
It's 160.
150?
160.
160. Oh, exactly 160. Now, we got this for an answer. Now, if I convert that into degrees, is that 160? Is 8 pi over 9 the same as 160? I see some students say, oh, professor, I don't know what. I don't know whether it's 160 or not. You can use conversion factor. I think it's what, 180 over pi? Way back, pi's cancel. This goes 20 times, 8 times 20, oh, it's 160. Now, this rainy day, even though this might be a little tough to understand, if you're not intrigued by this, at least you should be intrigued by it. Like, are you kidding? Professor, math is like that? All of a sudden I turn my finger in, I think there's no answer. It's not 10 pi over 9, and all of a sudden you give me the answer, it's 8 pi over 9. And then June checks it for me, and it is. You look at a nice little extra credit problem? Oh, Philip says, don't even put it down for extra credit, Professor. Just leave it off. Don't even put it on the test. As soon as I see it's gonna scare me, it's gonna throw my thoughts off, and I'll just mess up. Look how crazy this was. Crazy. So I gotta make sure if I would do one like this, it would have been extra credit. And I know when I first heard the student say, Professor, it's this. It is under certain circumstances, like over there. Boy, this is a workout here. But we confirmed it. The answer is 8 pi over 9. Okay, PK. Lord, let's move into something easier. What is it, a set of formulas? Is the formulas coming up next on the handout? Or not?
Yes, but there's one more, for the equation.
Solve the equation. My goodness, guys, I'm not going to solve it completely, just to finish it up for you. PK, as I am going to do it, but not solve it completely. To ask you to solve, I think what was 1 plus sine equals cosine squared?
2 cosine.
2 plus,
No, 1 plus sine theta
okay,
equal 2 cosine squared theta.
there you go. Now, I as a student, if I were a student, I would prefer on a final exam to see that to solve rather than one of these. Why? What might make this one easier for you? And who knows, it may not be that easy. Why might I consider this one to be a little bit easier to solve than what you saw earlier, like that was? What might you do? Or we have many more rainy days. You guys will be with me during spring. Oh, you'll be with me during spring. Wow.
sine squared plus cosine squared.
Thank you. All of a sudden I see a sine, all of a sudden there's a cosine in it. I can't deal with it if I have different variables to work with. So you're telling me you're thinking about sine squared plus cosine squared is equal to 1, which it is. And, hang on. Guys, I agree with you 100%. All this is tough. But, how be done. And what are you planning to do with that?
If we put it either instead of 2 cosine squared.
Right here?
Yes.
Replace that cosine squared with what?
1 minus,
With what? 1 minus
1
what?
minus sine
Yes.
squared, but times 2.
Yeah, and times 2. So you said, Professor, go to that identity and solve for cosine squared and make a replacement and rewrite this that she gave me to work. 1 plus sine, leave that the way it is, that's good. Here 2 times, and then replace cosine squared with this. Now, is everything in terms of sine now? At least I can solve it now, everything's in terms of the same variable, okay? Let me clean this up, and I may just factor it for you or do something to it, but I'm not gonna completely finish it up for you guys. 1 plus sine is equal to, down here is 2 subtract 2 sine squared.
Yes, and now we let u be sine.
Thank you. Thank you, thank you. It's one of those calling for let you be something here at this moment. First off, we're just move things around, make it look better. Move that 2 sine squared over, just make it look better. Plus sine, move the 2 over, subtract 2. And I think it looks like that. That's everything moved over to one side. And then let u be what?
Sine.
Sine. Look at this. And therefore now this becomes 2u squared plus u minus 1 is equal to 0. Now you're back across the street. You're in middle school. That's you like that. Now I think this, I hope this is factors. It's a little quadratic. I hope. 2u, you guys are a bit at factoring. Let me step back and see, I did not quickly, I think factors into that. Or you can use quadratic formula.
Yes.
Yeah, split this up, this will give you u to be a 1/2, and this is u is equal to a -1. Now watch me, I said I wasn't going to finish it, but I almost finished it here. What was u representing? Sine, so this says sine theta equals 1/2. Sine theta is equal to -1. PK, did they give me an interval on the side there in which to look for the answers?
Yeah.
From what?
Bracket 0 to 2 pi.
And the 2 pi is very open.
Yeah.
Okay, so guys, they want just the answers to fall down, finish this one out. Now, this is fairly easy now. Where have you seen on the unit circle, the y coordinate sine equal to a 1/2 to begin with? I've heard what? 5 and 6? Is it 30 degrees? And I think there's another place. 5 or 6. And Joseph, if, that's like 30 and 150. Well, those two fit here. So I can accept both of them. Where have you seen sine be equal to a -1? 35 or 2 is the only place it happens. That's 270. Guys, 270 also would fit with what she gave me on that interval, so you have 3 answers, and there they are. Wow. Now, better things are coming. Like comes up soon, the formulas. You'll love the formulas. You guys will step back. My goodness, PK, I think we're down to the formulas, aren't we? Guys, look at it. Board's full. June, I'm sure it's got all this, as she always does, so organized for us. So you can look at what she sends out, which is absolutely beautiful work she sends out. Guys, any concerns here? Okay. Now, if I came in and just did not do this, and then all of a sudden you leave me and go to MATH 7, and that MATH 7 instructor, and we all have different personalities. So, your MATH 7 instructor may have nowhere near the personality I do. From the patients, sometimes I do. Different people. They just go ahead and say, right, recount, oh yeah, I ran to. So here we go. Here we go. And you get your first quiz, you get a 0. Oh, don't, that'll not happen. If they stop me in the hallway and say, Brandon, did you have film in class during the winter? I said, yeah, I had film. What happened? So you were on the first quiz. I'm gonna find film. I'll find him. I said, what time are you sure calc class? Well, it's 2 o'clock in the afternoon. May I stop by before class starts? Can I just walk in before class starts? I'm going to interrupt you. Oh, sure, Randy, walk on in. And I see Philip sitting there. Or Joseph sitting there. No, don't do that. Okay, guys, we'll erase all this. I know, look how crazy it looks. Now, you guys were intrigued by this. You'll say, oh my goodness, it's amazing. It works like this. But you've got rules to follow, constraints to follow, all this to follow. Okay, now let's get something a little bit easier here. Try to get this chapter out of the way. We got to start out with something we discussed here, in fact. And all of a sudden it comes up in a formula here shortly. All this beautiful work. And as I erase, please keep in mind, my instructors were the highest and top instructors, especially in grad school. I just sat there in amazement. And amazed those numbers just went like that, and everything fit together, and I was sitting in my seat and while the professor was talking, with a smile on my face, I said, oh my Lord, I've never thought of math like that. This little piece went there and it fit. Then this went there, and that went there. And I walked down there, and took my quiz and got a 0. The smile went upside down. Loved the lecture. And all of a sudden I couldn't put the pieces together myself. That's where we need to practice. So you guys, let me get just enough room here, because I got so much to do here. Leave some of this on the board. Now, we'll make the next part easier. Like I said, it's formulas. I will start, starting over, we call this part 1. Now, I don't know what order I had those listed. Did I start out with a cosine formula to begin with or not? Or a sine? Did I do sine? Was it sine A plus B or A minus B? A plus B. Now, hold on, I'm not going to ask for the formula yet. And by the way, we are not going to, I'll discuss these. Sometimes I'll derive these, which takes forever. Maybe this is the formulas for you, and say this is it, we'll accept these. Joseph, what was number 2? Sine of A subtract B, baby? Hang on. How about the third one? A plus B, okay. And letter D, right, cosine A subtract B. These are the sum and difference formulas. Now, I don't have the formulas listed yet, you have them in front of you on the handout. Now, if I jump in and give you the formulas, and most, I'll probably give this without verification. I'm going to jump to for a reason. Hang on. Or should I? Of course I should. If I were a beginning student, I have these 4. Let's start with this one. I'd say, Professor, no problem. Why do you make math so hard? Cosine A subtract B, Professor. Shouldn't it be this? Shouldn't it be cosine A subtract cosine B? Like a distributive property. distribute cosine. Inside there, you get cosine A minus cosine B. And if I were a beginning student, I'd say, that should be the formula. But Joseph is going to tell me here shortly, that's not the formula. Okay, now suppose I had not given you the handout yet. And you did not see that formula for cosine A subtract B. You might say, without seeing it, you might say, Professor, just do this to it. And you got it. Now I want you to test something. That's that rationale. Let's try cosine. I'm going to try this, guys, see if it's going to work for me. Pi over 2 subtract, let's see if it's going to work, pi over 3. Looks like cosine A subtract B. Just move into it. And if I did think it's merely this, Professor, distribute the cosine. It should equal to cosine pi over 2 subtract cosine pi over 3. And you said, Professor, that's all you have to do. That should be it. Let's see what happens here. If I go back, though, just to justify this, these two put together, the common denominator of 6, I guess, or that really says 90 subtract 60. Does it really say inside there 90 subtract 60? Is that like 30? So should those be, if I should put them together with common denominator of 6, I think you'll end up with cosine of pi over 6. See if you guys agree. Is it inside there? Like fractions put together with common denominator of 6? Is it? Comes up to pi over 6? And then what's the cosine of pi over 6? I know that from the unit circle. The x-coordinate of pi over 6, I think, is this. Is that true? So the left-hand side says radical 3 over 2. If I did it like this, merely distribute the cosine inside there, it says cosine pi over 2, and that's cosine of 90. Who recalls what the x-coordinate cosine was up at 90? Oh my goodness. It's 0. And subtract now, who remembers the cosine, the x-coordinate at pi over 3, which is like 60 degrees? How much was it? 1.5? And therefore this side would give you this for an answer. Did the two sides give you the same answer? So I can't do that. I wish, goodness, I could do this. I can't. I cannot do that. That's a mere distributive property, you can't do it. So what's it going to take? Without a derivation. I wish I had time to do a derivation. And by the way, you guys who like geometry, it takes a geometric derivation. On the side here, since I'm talking about this one, Joseph, tell me, what on earth does it take for a formula there? Not distributive property, what was it? Cosine A. Okay. All changed to a plus. Plus what? Guys, it takes all this for a formula. Now we'll redo this problem with the formula that should work now and see if it works. You guys, so this does not work. We tried it. Now let's try the formula he gave me. Cosine of, here we go, pi over 2 subtract pi over 3, same problem. Joseph gave me this, let's fill this in. This says cosine pi over 2, cosine pi over 3, that's A and B, plus sine pi over 2, sine pi over 3. If I use the formula correctly. Woo! Now someone's going to have to help me. Does anyone recall what cosine of pi over 2 again was? Was that 0? And cosine at pi over 3 on the unit circle, what's the cosine of 60? Is it 1/2? So far so good? Sine of pi over 2 was what? 1? And what's the sine of pi over 3? Who recalls what the y coordinate of pi over 3, sine of pi over 3 was? Help me out, guys. Was it radical 3 over 2? Help me out. Was it? Yes or no? So this drops out, and you're left with, what's that, radical 3 over 2 for an answer. If I use the formula correctly. Oh, by the way, did we say earlier it should be radical 3 over 2? Did we? And did we actually, this time with the help of the correct formula, did it come out to be radical 3 over 2? That's the formula. That's my formula for cosine A subtract B. Now, on your handout are the other formulas. I listed them for you. So it's going to require you to know your cosine sine formulas. Guys, don't let me make a mistake. We put this in real quickly. Sine A plus B, I think looks like this. Is it sine A cosine B plus cosine A sine B? Yes or no? And that's the way it looks on your handout. This one, sine A minus B, I think, I'm going to put the formula here. If you know one, you'll know the other. The sine A cosine B minus cosine A sine B. Joseph, make sure I get all this copied out correctly. Don't let me mess up. And I'm gonna do this. That's that one. All right, the formula's correct so far. This one, cosine A plus B, is cosine A, cosine B. Is it a minus here? Someone remind me. In my head, was it a minus there? And that's my formula for cosine A plus B. Jeez. Philip, class, I wish, oh, do I wish, that this was merely cosine A plus cosine B. Oh, do I ever wish that this over here, up here, would be sine A plus sine B. I wish it doesn't work that way. It takes that long formula. But I think if you look at these formulas, you know one, I think it's only a little sign change, you'll know the other. Okay? Now, a student asked me, not too many days ago, said, Professor, part 2, suppose you're asked to find this. And I may have started out with that on the handout. Sine of, let's say, I'll put it in radians. No, I'll put it in degrees first. Sine of 15 degrees. And that's not one on the unit circle. That's not an angle on the unit circle. Does anyone know, just out of curiosity, what 15 degrees looks like in radians, if I should convert it? Just out of curiosity. Is that pi over 180, I guess? That's my conversion factor. Cancel. Is that 12, guys? Help me out. Is that pi over 12? So I could say this is the same as sine of pi over 12. If you want to do it in radians. But I want to know the answer. Now, can anyone tell me, based on what you see right now today, how might you find it?
You subtract sine of 45 degrees minus sine of 30.
Look at this, Professor. You're going to take 45 degrees, subtract 30 degrees, and those are angles that I can deal with on the unit circle. That's 15 degrees. Now, she's made this look like sine A minus B, which says eventually I have to go back to this formula here to get the answer. Sine A minus B. And 45 subtract 30 is 15. Julian will put this in radians. So you're telling me take sine of pi over 4, looks a little bit better, subtract pi over 6. Same thing, just radians. But we still want an answer. Now what's that answer? It all depends on this formula. So the formula says take sine A, now guys, we're doing in degrees here, sine 45 that she gave me, times cosine B, which is 30. That was given to me. Subtract cosine 45 sine 30. If I use my formula correctly, this one. Now, can I make replacements? Yes, all this takes me back to the unit circle. If it doesn't, you have to use a calculator. Okay, let's see what happens. Sine of 45, we should all know. Radical 2 over 2. Cosine 30, everyone in class should know cosine 30. What is it? Radical 3 over 2. Cosine 45, we all know. Sine 30, 1/2. And if I do a calculation here, we'll finally get an answer. This says radical 6 over 4, subtract radical 2 over 4, better expressed as this all over 4. Now what is that? It's not on the unit circle, but what is it? That's the exact value for sine of 15 degrees. That's its value. You could not find this on the unit circle, you had to use a formula. You guys with me? Okay. Yes, PK.
Can you write it radical 4 by 4 over 4?
Do it again now.
Can you write it radical 4 over 4? The answer.
Oh, got you. PK, class, oh, maybe the other members of the class will think the same thing. You say, wait, Professor, can I just go ahead and put those two together and take 6 subtract 2, right? And make it square root 4? Can I? No. There's no rule to follow that. You gotta do it like this. Oh, I'm glad you brought that up. Just in case some of your classmates were thinking the same thing. You cannot call that square root 4, 6 subtract 2. You can't do it. You gotta do it like that. Now guys, it's a sine of 15 degrees. Now, I see it's on, this will probably take me up close to break. Now we'll try one more with you and see if someone can make a conclusion for me. Number 2, I'd like to find this time, and PK, did I have some of this on the handout? Oh, I did. I don't know, sine of 15 degrees, was sine of 15 degrees, or sine of pi over 12, was that on there?
7 pi over 12.
Oh, that's 7 pi over 12. Okay, I'm gonna find something else first. Guys, we got the answer to this. This is this. Then we'll try one more. They're getting a conclusion here. I'd like to find the cosine, if I can, of 75 degrees. Let me quickly convert with your help. What does that look like, just in case I went into radians before I jump into a formula? What is that, cosine of what? Does anyone know what 5 pi or 75 degrees would look like converted into radians? Or you can use a conversion factor. Does anyone think they know what it is? Before I jump into a formula? 75 degrees?
35.
No, I want what that would just look like in radians first. I'm going to use the formula again. In other words, use a conversion factor, something like this. What would 75 degrees look like? Anyone? Not pi over 4.
It's 3/4 out of pi over.
Oh my goodness. I might have to make a call, contact the college and say, you got to change my class schedule for spring. And they say, Ramsey, why? Well, my winter class didn't quite finish. Whoa, I'm hearing something over here. My winter class did not quite finish. SMC. What are we going to do? We're going to bring them back. All of them? Joseph also? PK also? All of them. Just bring them back. We'll do it again. Now he's telling me, tell me again, Joseph. Pi over what was it?
4.
And? Now he says that's 45 degrees plus 30. Is that 75 degrees? You want to do it in degrees? And I think the original 75 degrees could be expressed as, what does that look like? Is that 5 pi over maybe 12? Someone check that out for me, see if that's true. At 75 degrees, if you convert it by using a conversion factor into radians, is it 5 pi over 12? I'm looking at it quickly. Is it? So you're actually finding that. Now he tells me, Professor, these two will add up to 5 pi over 12. I know I have to use a common denominator of 12. I have to multiply this one by 3, so I've got 3 here. I have to multiply this one by 2, I've got 2 here. So 3 plus 2, will that give me the 5 pi over 12? So could that 5 pi over 12 be written like that? Yes. Now, since you've written it like that, Joseph, you have written it for the class, and I'm doing this for a reason, in the form of cosine A plus B, which requires, look at this, where is it? This formula. Now, to apply this formula on what he gave me. To apply it, here we go. It says take cosine A, cosine pi over 4. Next to it, cosine B, cosine pi over 6. And it looks like it's a minus here. Sine of pi over 4, if I look back up there, and sine of pi over 6. Very good. Stopping point here shortly. By the way, guys, did I put things incorrectly here? On the formula. Okay. Now, would it help if I place these formulas on the test for you? Look at those guys going, yes. Am I? Mm-mm. Mm-mm. Zoe was shaking her head like, yes, Professor, please. Put that formula down there on that test so I can see it. No, I'm gonna do it. I'm gonna finish it up. This is cosine pi over 4, radical 2 over 2. He has taken me back to the unit circle. Where'd you, let's go. Cosine pi over 6, radical 3 over 2. Sine of pi over 4, radical 2 over 2. God know this. And sine of pi over 6, sine of 30, 1/2. He took me back to the unit circle. Hang on just 1 second. Let's see what that answer may look like. Guys, here goes. That's equal to radical 6 over 4 minus radical 2 over 4. It's right here, guys. Radical 6 over 4, subtract radical 2 over 4. I'm back. Whoa, hold on. Is that all over 4? Wait. Did we get this last time? Did I make a mistake? Let's see, head shaking up. Professor, you didn't make a mistake. You said something. Same answer. And this will take me right to closing. So set up here. Can you want to tell me why on earth this was 15 degrees? Sine of 15, I got this answer by using the formula. Then all of a sudden I changed it to cosine, completely different trig function. 75 degrees, completely different angle, not 15. Cosine 75 degrees, and we crunched it out by formula and got the same answer. I'd like to know, let me step back just a second, guys. What's making that happen? And should I be on the alert for this happening? What do you see there maybe that says, Professor, I think I see why you got the same answer. There's something going on here. That's what I need. Joseph, what do you think's going on?
75 degrees.
75 degrees is 15 degrees from 90.
Yeah, X.
I agree with that.
It's like putting whatever the y is, or inside of y. Like, how do you mean?
You You are so close, I agree 100% there with what you said. You're so close to what they accepted math of why this is going on. So close. Junior.
Because if you make a triangle with that same, they flip the x and y, it's kind of like the inverse, but not, it's not the inverse, but if you make a triangle.
You mean a right triangle?
Yeah, it has the same degree because it's 15 degrees from 90, but the height and width. of
It's
the
75
triangle-
degrees? I got you. Very close to what they want. Both of you guys very close. Something easier than that. Joseph, something easier than what you said. There's something staring at you. It says maybe, maybe. That's what it takes to make these answers come out to be the same. What is it?
Cosine A minus B equals cosine A
Ooh,
plus.
easier than that. It's just staring at you. Now, I'll give you a little hint. I'm not writing anything on the board right now. I'll watch the time here. I gave you 15 and 75 on purpose. If I had given you 15 and 60, 15 and 60, not 75, it would not have worked. If I had given you 15 and 40 degrees, not 75, this would not work.
So if
What's
we,
so special?
if we sum the angles, it will give us 90.
Jump again.
If we sum the angles, it will give us 90.
Those two angles must sum up to 90. Very close to what you were telling me. If they sum up to 90, you're guaranteed, if you take sine of one, you'll get cosine of the other. Now, it's a good stopping point. When I give you the names of the 6 trig functions, remember sine and cosine, and tan and cotan, and secant and cosecant, there were 6 of them? I didn't tell you anything about it, I just gave you the names, you guys accepted the names. Those are the names. And I gave you the abbreviations, COS, SIN, all that business, and the definition. This one, hang on. It is cosine, of course, that's its name. But guess what's inside the word cosine itself? And I did not tell you when I put this on the board, which now I need. What is it? Sine's in there, for sure. Hang on now, hang on. Oh, okay, so sine is connected somehow with cosine. They were connected here. Somehow cosine and sine have a relationship.
It's a right triangle.
Tell me more. I see the word sine. How about the CO?
Complementary.
Ah. Usually I ask Jude, before you get it to me, I usually ask you, what does the CO? I see sine in there. What's that CO out there from, and cosine also representing something? And I ask students to give me a math term, vocabulary, something you recall from math somewhere that starts with a CO. And I'll get a student to say coefficient. That's CO. It's not what the one I want. And complex. That's the CO word. The other one I'm looking for here to make things work is, and I heard it, was this. Complementary. Does anyone recall, if you saw that word back in middle school, what did they mean when you say it? And there's also another word, supplementary. Does anyone remember anything about complementary?
Is the nearest side to the angle.
The two angles should sum up to 90. If it's supplementary, they should sum up to 180. That's what the CO means in cosine. You're taking sine of the complement. Complementary angles. Who would have thought? Now, before we close out, take a well-deserved break here. I'm not doing anything crazy here. So if you're asked to find the cosine of 10 degrees, you should quickly say, Ramsey, is equivalent to sine of how much? 80 degrees. As long as they add up to 90. They are complementary. Guarantee those two will be the same. Answers. As long as the two angles are complementary, they add up to 90. Wow. Oh, by the way, before you leave for the break, are there some other CO words that we, had besides cosine? Cosecant works the same way. Look at this, cosecant, CSC, okay, cosecant. And the word cosecant, guys, is what, secant?
Yes.
Cosecant. So if I say find secant, let's say 5 degrees, that should be equal to what? Is it cosecant? And how much? 85 degrees? Is it true? See how it works? And was there one more? CO word, cotangent. Cotangent with tangent should work. Same thing. The CO means complementary. When the angles add up to 90, you got it made. PK, before we take a break, if they do not add up to 90, you got issues. If that were a 70, forget it. They are not equal. So up to 90, you're in good shape. Wow. You guys okay? So you don't think I should rearrange my schedule for spring, do you? Because I'm just all excited about this new building. Wait till you get inside that new building. And I guarantee you, when you first walk, you guys, I'm sure all you guys will be with us for spring. When you walk into the new building, we're all gonna be lost, it's so huge. I have to find my office. Then I have to find my classroom. And you guys will be searching for your classroom, so they're gonna put lots of things posted around to help you find where you are. Wait till you see it. It's exciting. And this building's gonna be left empty. Guys, any concerns? So I should tell my colleagues, I saw one look through the window today, just a few minutes ago. So should I tell my colleagues that my class is still the strongest class ever? Right? So I don't want you to find you, Bill? So I don't want you to go out and find you, okay. PK, I'm not searching for you, unless I hear something, no, I'll find you. Okay. Okay, guys, take a 15-minute break. We got a quiz tonight also, a short quiz. Okay.